In this episode, we will talk about gravitational waves. Let's enjoy it. The gravitational waves were discovered theoretically by Albert Einstein himself, although subsequently he believed that his calculations were wrong. Einstein realized that the weak field approximation of his equations is linear and that they describe the propagation of a wave moving at the speed of light. For understanding what is a gravitational wave, we have to understand first the concept of wave. There are different types of waves. We have mechanical waves, just like the sun or like the water waves, for example. This type of waves require a medium of propagation. In this particular case, the wave is just a disturbance of the medium itself. We also have electromagnetic waves, which don't require medium of propagation. These include waves of radio and the light itself. These waves travel at the speed of light in vacuum. Finally, we have gravitational waves. Gravitational waves appear, for example, as a consequence of the collision of two black holes, which after rotating around each other for a while finally merge, producing in this way vibrations or ripples stretching the space-time itself and propagating at the speed of light. Note that gravitational waves and electromagnetic waves both propagate at the speed of light in vacuum. However, both types of waves have strong differences. One strong difference is on the mechanisms of generation in each case. From one side, at the lowest order, the electromagnetic waves are generated by time variations of an electric dipole. On the other hand, the gravitational waves are generated by variations in time of a quadrupole at the lowest order. The monopole contribution cannot generate gravitational waves because it corresponds to the mass of an isolated system which is conserved. The dipole contribution cannot generate gravitational waves neither because the center of mass of the isolated binary system doesn't change location over time. The first evidence of gravitational waves was observed in 1974 by Hall and Taylor. Observations by them confirm general relativity, which predicts that due to the loss of energy through gravitational rotation, two bodies rotating around a common center will be approaching to each other over time. The Hall-Taylor evidence was an indirect proof of gravitational waves. Later, the first direct detection of gravitational waves was done by the LIGO detector, when they could find the waves generated by the merge of two black holes which were rotating around each other. Even the rotation of the solar system's planets around the sun generate gravitational waves. However, these waves are very weak and undetectable with the current technology. LIGO detection corresponds to high-frequency gravitational waves, coming mostly from violent events. Low-frequency gravitational waves and more monochromatic events have not yet been detected so far, but they are planned to be detected subsequently with a triangle of satellites located around the Earth. Gravitational waves are evidently weaker than the electromagnetic waves and more difficult to detect. However, at the end, this represents an advantage for the gravitational wave spectrum. Precisely for being so weak, gravitational waves suffer less scattering than the electromagnetic waves, and as a consequence they can provide more information coming from the original event originating them. For understanding this issue, let's provide an analogy. Here Charles is kicking the soccer ball. By knowing the dynamic of the ball, it is easy to know the details of Charles' motion in order to kick the ball. This is clean information. In a similar way, gravitational waves provide clean information to us coming from the cosmos. However, if Charles kicks the ball, and then this collides with several obstacles and difficulties, including fire for example, then for us it would be really difficult to analyze exactly what Charles was doing at the moment of kicking the ball. In summary, gravitational waves are real and they have been observed experimentally. They are considered to be an additional proof of Einstein's theory of general relativity. Gravitational waves open a new window for a deeper understanding of the universe. Basically, they will allow us to obtain information of the universe which is not possible to get through the electromagnetic waves. If you liked this video, please give us a like, share the link and subscribe to the channel. More videos are coming very soon. Continue with us.